Now, electrodynamics, what are my expected definitions? I must be able to define a generator. A generator is a device that converts mechanical energy to electrical energy. And a motor is a device that converts electrical to mechanical. Principle of operation: generators work on the principle of electromagnetic induction, while motors work on the principle of the Moto effect. You cannot forget that of a generator. Generators work on the principle of electromagnetic induction. Faraday's law of electromagnetic induction. All right, the white is not showing. Principle: Faraday's law of electromagnetic induction. That is for a generator. And a motor, simply motor effect. The different types of generator, we know we have AC and what? DC. And for AC, you know what we have? We have what? Two slip rings. And for DC, we have what? Split ring commutators. And I told you how to remember. If you take a ring, if you split it into two, that is your D. And that is your C on the left-hand side. So you can see I am splitting. Please don't write split ring alone. Here is what's giving you a mark. It's commutators. All right? Parts and their uses. And then the last definition, root means square. I'll talk about the parts when I see a diagram. Root means square. You must be able to define. I think we'll define along the way. That's the basics. Things you must know. Check this. Learners want to build a small DC motor. Write down 3 essential components that are needed. That's what I mean by parts. What do they need? Number 1, they need a coil. And the coil is supposed to cut through the magnetic field. That's the function. The coil will cut through the magnetic field. All right? Number 2, what do they need? They need a magnet. What will the magnet do? It will produce the magnetic field. And number 3, since it's a DC, what do we need? We need commutators. Okay. We need a coil, we need a magnet, and for DC, we need commutators. It's a DC motor. Yes, thank you. We need batteries. We need a power supply. Good. Because we are changing electrical to mechanical. Lovely, Fat Rab. Thank you. Beautiful. And you're done there, guys. Let's get this 9 marks. An electrical device with a resistance. Guys, if you've been following, you know that I read very slowly to be able to get all the information out. My resistance is 11 ohms. Connected to an AC source with an RMS voltage. Oh, beautiful. So we know our VRMS. I told you that this definition would be there. Define RMS voltage. It is the AC voltage that produces the same power as a DC voltage. AC voltage that produces the same power as a DC voltage. If the examiner says RMS current, then you change that AC voltage to AC current. Quickly, I'm going to tell you advantages of AC over DC. Let me put it here. I'll go back and answer that question, but I don't want to forget this. Advantages of AC over DC. Okay, let's go answer this question now. Calculate the maximum, guys, maximum current. Easy stuff. Maximum We are looking for I max. So you check your formula page. What is it that I have? Oh, I have VIR, which is basically Ohm's law. But here is the deal. If I'm using RMS, so if I say I know that V equals to IR, guys, if I use VRMS here, I am also working with IRMS. Take note. So what's my VRMS? 240 equals to IRMS multiplied by 11. It therefore means I can get my IRMS as 240 over 11. And we are looking for Imax. We know the formula. IRMS equals to Imax over root 2. I'm sure everybody remembers that. You get that from your formula page. So do I know my IRMS? 240 over 11. I'm sure you know what to do. Do you want to give me an answer? Let's do the maths. Give me an answer. $30.86. Thank you. A, and we're done. End of story. 9 marks, 9 exam. Voila, good. Okay, advantages of AC. Thank you guys. Over DC. Let's quickly look at this. All you need to know is about 3. Number 1, AC can be converted to DC easily. And I'm going to quickly explain something on this. Easily. I'm going to quickly explain something on this. Guys, in your generator, every time you use electromagnetic induction, electromagnetic induction will always produce AC. It's going to make sense to you now. Will always produce what? AC. So if I have my that there and I have my magnet, now check what I have here. I am going to use commutators, and I'm sure you know what those are. Those are, we are producing it's a generator, all right? So we are producing electricity, but these are what? Carbon brushes. And what are the functions of carbon brushes? To act as a conduit or flow, to act as a connector between the rings and the external circuit. All right, now here's what I want to show you. So we have a generator here, okay, that we are turning with a handle. If I ask you this, you tell me that this is a DC. All right. Okay, Sophie, that's my second point. You will tell me that this is a DC. But please take note. I'm not arguing that it's a DC. But right here in the coil, right here in the coil, what we are generating is AC because of electromagnetic induction. So in the coil, we are generating AC. It is the commutators that convert it into DC. Hence we said AC can be converted to DC easily. That's advantage number 1. I hope it makes sense. It brings a better picture when we say it can be converted to DC. As long as there's electromagnetic induction, we will produce what? AC. Number 2. AC can be stepped up or stepped down easily. by using a transformer can be stepped up or down easily. Number 3, AC is cheaper. Number 4, AC can be transported over long distances with high voltage. That's why you see all those signs. It will always tell you high voltage. It's because it's AC. High voltage, low current. And what is the main aim here? To reduce power loss due to energy conversion to heat. That's why, guys, if you hold your cable, you will see it's warm, because we are already converting electrical energy to heat energy conversion to heat. All right, so we are using AC. So in the wires that you see outside, all those big cables, it is AC being transported. If we use DC, those wires would be very hot because we'll have to use high current. Okay, now these are a few advantages of AC over DC. If you just know 3, you'll be all good. Now let me answer one more question. I promised by 8 to shut down. Okay. Let's quickly look at this. The diagram below shows a simplified, I almost said sanctified, God, a simplified version of an AC generator. All right. We are told it is an AC generator. Okay. How do you know it's an AC? You can see here it has what? Slip rings. Those are my slip rings. And you would see A and B are the carbon brushes, which serves as a conduit. Okay, thank you. Now, name the component in this generator that makes it different. Oh, Sophie, you were answering. Okay, slip ring, we're done. Sketch a graph of induced EMF versus time for 2 complete rotations of this coil. All right, guys. When the coil is standing vertical like this, when it's standing vertical, we are actually generating 0 EMF. All right, it's a 0 EMF. So let's quickly sketch. When it is standing, it is generating what? 0. But it's an AC, right? Remember? And the examiner wants to, oh, please, I am going to say something here. Very, very important. That's 1. Examiner wants 2. That's 2. Please permit me to discuss something quickly with you. All right, we need to label this EMF and time. All right, quickly. Permit me to discuss something here with you very fast. This is EMF versus time. This is what I want to discuss with you quickly. Please, I need you to stay focused here. How to increase, and I'm using this graph, increasing the current generated. Increasing current generated. Or increasing voltage, potential difference. You know there are basically 3 ways. Number 1, we increase the number of turns. All right. Here is the graph for that. Let me reduce this thing to make it easy for me. So I'm just going to get one AC graph. All right. Number 1, we increase. I'm going to label the graph for you. All right. This graph would be representing increased number of turns on the coil. And number 2, it will also represent using a stronger magnet. Because you can see the amount of potential difference generated it has been increased. However, if I then give you a graph that looks like this, same amount of current, okay, forgive the skewness of the graph. Now, you would notice that we have also increased current here, but what are we doing? We are increasing the speed of rotation. That's why we have more frequency. Increasing the speed of what? Rotation of the coil. Please take note. Those are the 3 things that we can use to increase current, but look at the graphical representation. Increase the speed of rotation of the coil. It means there is more rotation. We have more frequency. Frequency is the number of waves, complete waves, that passes through a point in 1 second. All right. So we are saying if you rotate twice, then you have more frequency. Please take note of that. Very lovely concept there that examiners can throw at you. Looks beautiful. All right, let's end the class by finishing this question. A practical version of the generator above has a large number of turns on the coil, and it produces an RMS potential difference of 240. Write it down. VRMS equals to what? 240 volts. State 2 ways in which the EMF induced can be increased. Done. Define the term root mean square value of potential difference. Done. Because we defined AC RMS voltage earlier on. A practical version of this generator above is connected across an appliance rated. Please take note of this. We are given power 1,500 watts. It is important. Whenever you see power, power is associated with RMS. Some of us get confused with what? RMS. Also, take note, socket voltage is also RMS, the one from your houses. So examiner might bring in that word. No, socket, not socket. English never loved me, guys. You know that. So once you see socket voltage, it is referring to RMS. Power is also referring to what? RMS. Because the formula says P average equals to what? I RMS. Please take note of those. What are we looking for? Calculate the RMS current. Oh, we have power. Easy. IRMS, we don't know. What about VRMS? We know 240. Oh, do you want to give me an answer here quickly? Dividing both sides by 240. Chaplile, why are you laughing now? What is your answer? That is yay. What is answer in Afrikaans? Atword. Aha, thank you. Donkey. Vat. Hey, you guys, the way you guys are responding Afrikaans. My God, ek praat nie Afrikaans. Me, I don't speak Afrikaans. Ek praat nie Afrikaans. I only know ek is moeg. Jablile, please. All right. But guys, I hope it's okay. What we did so far, are you happy with looking at this concept? Yes. Kaylee, you know Afrikaans doesn't love me, you know that. But I'm trying. I'm trying. Oh, there's another one. Oh, can I do this in 10 minutes? I promised I don't want to take more. Yo, there are so many. Jeez. Oh, it's just two. Okay, let's see. Let's see. I'm going to run. Oh, it's one question. The diagram below shows the output of a generator installed. Guys, if you look at this graph, what type of generator is this? Quickly. What type of generator is this? Thank you. It's a DC. Does this... done. Explain. Current is flowing in one direction. All right, no, not current now. Voltage is in one direction because it's voltage on the Y. Voltage is in one direction, and you'd see that. If it was an AC, then it would have been that. Thank you. Name the principle under which generator operates. I answered that. Faraday's law of electromagnetic induction. We cannot forget. All right. State the energy conversions that come on. Generators convert what? Mechanical to electrical. You see, getting the marks. Which structural change should be made on a DC generator in order to convert it to an AC? You want to tell me that? How do we convert a DC generator to an AC generator? I'm waiting on you to give me that answer. How do we convert a DC gen to an AC gen? Somebody? All right. We change from split ring commutators. Thank you, Lonel. And change them into what? Slip rings. Done. Okay. Now, which of the following diagrams, A or B, correctly illustrate the position of a coil at a time of 0,05? Let's go check 0,05. What are we producing? Check. And I think I answered this question. We are producing 0. Can you see there? Which one is correct? A or B? A. I told you. Sophie, why B? It cannot be B. Sophie, you cannot lose that 1 mark. Tanami, please. I did mention it earlier on. It cannot be B. When the coil, do you remember it's still here? When the coil is standing vertical, I did mention that. There we go. When the coil is standing vertical, we have 0 EMF. All right. 0. And remember when I even explained, I remember talking about, you know, two people who are in love. That's a, it's standing in between. They cannot see each other. So love is 0. All right, there's no chemistry because they are blocked. Love is 0. State 2 reasons why a generator would be less than 100% efficient. That is, state 2 ways that energy is converted into other forms other than electrical energy by a generator. Yes, Katia, you know how I roll. Guys, what type of other energy conversions can we have? Number 1, the electrical energy that is supposed to be produced is lost to heat energy. All right, lost to heat energy because the generator becomes hot. All right, when the generator is working, it produces it gives a vibration. It even gives sound. It's lost to heat energy. All right, converted to heat energy. What else? Okay, let me answer this well. What energy are we converting? Mechanical, right? So we are going to say the mechanical energy which is supposed to produce electrical is converted into, your generator becomes warm. Number 1, heat energy. Number 2, it makes noise. Sound energy. Number 3, it vibrates. It's a lot of energy for it to vibrate. Vibration energy. You know, you can just create things here. All right. List two ways of increasing the output of a generator. Now, check this. Do you see this question? List two ways of increasing the output without affecting the frequency. I answered this question not even knowing it is here. Without affecting. So please take note of how these changes occur. Without affecting. Which one are we going to mention? The one at the bottom. Increase the number of turns on the coil and use a stronger what? Magnet. Once you say rotation, it affects frequency. I hope we got that. That was answered way long before we even got here. Oh, I actually made it. And that is generators and motors done and dusted. Guys, that's it.